Hey guys, my name is Ali Al-Jubairi. I'm an electrical engineering student at the University of Michigan Dearborn, and today my classmate Khalid Omar and I are going to give you a little insight about computer vision and image processing as applied to the automotive industry and autonomous vehicles. What is image processing? Image processing is a process that uses different operations, different algorithms, and different techniques in order to improve the quality of an image or a video. It also allows you to filter out unimportant information from an image or a video and to decipher the physical contents of an image and video. Another thing image processing allows you to do is to remove noise from an image using a noise reduction algorithm. So you're able to remove, say, dust, scratches, speckles, anything that interferes with an image or may mess up an image can be removed using these algorithms in order to create a new and enhanced image. So some may ask, what is image processing used for? Image processing can be used for image editing, image restoration, pixelation, and object detection. For image editing, there are image editors out there available that allow you to select parts of an image without affecting the entire image. Image editors also allow you to resize images through image scaling, making them either larger or smaller. And some image editors even allow you to crop out a portion of the image. There's also so many other features that come with these image editors, but we won't get into too much detail. Image restoration is basically taking a corrupt image and producing a better and more enhanced image. When I say corrupt, I mean images that can come in forms such as motion blur, noise, or for example, when a camera loses focus. Pixelation is basically a bitmap or a section of a bitmap that is zoomed in just enough to where individual pixels become visible. You can see an example of this on the bottom left of the screen. Here you see an original image go through a pipeline and eventually reach a pixelized image. Image processing is also used in object detection because it deals with detecting anything. It deals detecting anything from people to cars, road signs, and even buildings in images and videos. As you can tell from the image on the right, the vehicle is being detected by an image processing system. There are many different transformation filters that can be applied in image processing. These filters include spatial high-pass and low-pass filters, Fourier transformation, template matching, Laplacian of Gaussian filter, and difference of Gaussian filter. A spatial low-pass filter, also known as smoothing, can be used to remove high-frequency noise from a given digital image. On the other hand, a spatial high-pass filter, which is the exact opposite of a low-pass, can be used to amplify noise and sharpen an image. A high-pass filter works just like a low-pass filter, but the convolutional kernel it uses is different. Moreover, Fourier transformation can be used to break down an image into its cosine and sine components in order to gain high-level understanding from images and videos. There are also filters that act as templates. An example of this, like I mentioned here, is template matching. Template matching uses normalized cross-correlation to find a given pattern or template in an image. Next up, we have the Laplacian of Gaussian filter, which basically acts as an edge detector. It's useful for detecting edges that show up at different image scales. And last but not least, the difference of Gaussian filter removes high-frequency detail, which may sometimes include random noise that can mess with an image or a video. As you can see from the image with the two moons, the image on the left is the original image, and on the right, you see the representation of the same image after a low-pass filter has been applied. And then, in the image right under it, the butterfly image, this is an image that has gone through a Laplacian of Gaussian filter. Image processing is used in many application fields. Some of these applications are automatic inspection, assisting humans, organizing information, computer-human interaction, military use, and also it's used in the automotive industry. Automatic inspection uses image processing in manufacturing applications such as position and orientation being measured in order to be used by a machine or robot. Computer vision can also be used in assisting humans in identification tests such as detecting an object. Also plays a huge role in detecting events in visual surveillance or counting species, for example. Um, Image processing can also be used in computer-human interaction as an input to a device. Also, computer vision can be used to organize information by organizing databases of images and image sequences. One of the most important uses is in the military and automotive industry. In the military, computer vision is used to detect enemy soldiers and vehicles, and to track down missiles. Um, and then the automotive industries, as you guys all may know, are working with autonomous vehicles, which use computer vision systems that assist a driver in many different situations.
What are autonomous vehicles? Autonomous vehicles are a self-driving vehicle that has the ability to sense its surroundings without human interaction. There are different levels of autonomous vehicles. Some of these levels range from fully autonomous to semi-autonomous vehicles, meaning they may require some human interaction. Autonomous vehicles use cameras to do the image processing. The cameras that are equipped in the image do the image processing. Some automotive manufacturers are working on cars that are fully autonomous, meaning they are unmanned. For fully autonomous vehicles, companies are using computer vision to navigate the car around. They use it to know where the car is, to detect obstacles that may be in the way, and to produce a map of the environment that is surrounding the vehicle. Also, in the automotive industry, companies are using computer vision in supporting systems such as obstacle detection systems and cars or lane detection systems that help keep the car on track when it is in motion. Obstacle detection systems are extremely important to implement to a self-driving car or semi-autonomous vehicle because the car needs to know what to do if an object shows up in the front of it while it's driving, or if a pedestrian is crossing the road. The car needs to have an understanding of this. Some image processing approaches to autonomous vehicles: point operators, affine transformations, perspective transformations, Hoff transformations, Raymer-Douglas-Peaker algorithm. Point operators are used to provide image processing transformations. Point operators are capable of performing color transformations, separating the image into two different layers, histogram equalization, and tonal adjustment. Affine transformations save symmetries and a distance ratio when it is applied to a specific point of an image. By using affine transformations and saving the ratios of a specific point, it allows for rotating, scaling, and translating of a geometric shape. Perspective transformation is used to calculate the distance between a camera and a certain pixel of an image. The distance is calculated by using a perspective matrix transformation that applies a z-coordinate to every pixel of that image. The z-coordinate then replaces a y-coordinate in the image and uses 3D space to represent points that are closer or further away from the camera. The pixels that are closer to the camera are represented at the bottom of the image, and the pixels that are further away from the camera are represented at the top of the image. Hoff transformations is used to convert each component in the picture from a Cartesian coordinate system to a polar coordinate system. The main purpose of the Hoff transformations is to separate the parameters of the lines in an image. Hoff transformations have a high tolerance for noise, so it allows it to be very useful. Another image processing approach that is used is the Raymer-Douglas-Peaker algorithm, which is used to make things simpler. The Raymer-Douglas-Peckel algorithm makes things simpler by decreasing the amount of points in a curve. By decreasing the amount of points in a curve, it allows for time efficiency and makes processing a lot simpler. We may not know it, but there are many computer vision systems in our vehicles today. These computer vision systems are being used in regular vehicles and autonomous vehicles as well. Some of these systems that are being used are adaptive cruise control systems, lane departure warning systems, driver fatigue systems, and vehicle detection systems. Lane detection assists the occupant of the vehicle when they're attempting to switch lanes. It is also a very important aspect in autonomous vehicles because it will allow the vehicle to switch lanes. The two key elements for lane detection to work are image enhancement and edge detection, and lane features extraction and road shape estimation. Lane feature extraction uses an algorithm to determine the form of the lane and also estimates the position and shape of more lanes that are nearby. Adaptive cruise control systems use image processing to determine if the vehicle should speed up or slow down by detecting and analyzing the speed of other vehicles nearby. Another feature that is implemented in vehicles that uses image processing is driver fatigue detection. This will help in determining if the occupant of the vehicle has fallen asleep, is becoming drowsy, or is not concentrating on the road. The three different procedures to detect if the occupant of the vehicle is becoming fatigued are analyzing the occupant's current state, which is looking at the occupant's head movements, how the occupant is operating the vehicle, is the vehicle swerving into other lanes, etc., and combining both the occupant's current state and the occupant's driver performance. Another computer vision system is vehicle detection. The two steps in how vehicle detection is processed are determining which candidates in the image could be a vehicle, and running tests to ensure the existence of a vehicle. There are three different ways in determining which candidates in the image are vehicles: knowledge-based methods, stereo vision methods, and motion-based methods. Autonomous vehicles are the future of the vehicles on the road. The promises that these vehicles bring are safety, better vision, and awareness than humans, and it will improve time efficiency on the road. Although this sounds a lot easier said than done, before we know, we will be a part of this project that will eventually become our reality.